I don't know when we're supposed to get started, my friends.
Right now.
Okay, good. Let's do it right now. It's 10:38. So how long do each one of these run? Hour. So we have this oddity of a schedule. I have a second talk here as well. So I'm going to just make them one big 2-hour talk. It's going to be fun. It'll be interesting. If you like what you see here, you'll benefit from what you've learned, and it'll be particularly useful in the second one. I wasn't sure what the schedule was a little confusing, so there was supposed to be a hands-on lab that we sent out instructions. That code is on GitHub. Please download it. Maybe you can install it. You'll be able to see what we're doing, and you'll understand what's happening as we go through this talk. Okay? So I will definitely be doing hands-on, and you can follow along at home. By that I mean right there. So please. Okay, before we get underway, a few things of great import. Absolutely critical that we get right, or we just won't be able to proceed. First of all, I need a photo. So can you guys say open source? Open source. Oh, it's so good. It's so good. It's money. I love it. I love it.
I blanked.
Oh, do it again. Oh, yeah. Who's my friend with 2 thumbs?
This guy.
Yeah. Yes. Right, good. So anyway, morning everybody. How's the show treating you?
Good.
Oh, yeah. How many of you are hungover? I'm just asking. Asking for a friend. Anybody? All right. Well, technical conferences. Good. So about me, I'm Josh Long. I work for the Spring team at Pivotal. I'm the lead author of 5 different books and 3 best-selling video series and so on. The latest and greatest of which are both on Boot and Cloud and Cloud Foundry and microservices. Oh my! I'm a contributor to. I like to joke, but I'm not joking. Or am I? Or am I not? I'm a leading contributor of bugs to many fine Spring projects, not the least of which is Spring Integration and Spring Boot, which we'll talk about today. I work at Pivotal. How many of you have heard of Pivotal? Okay, that's a little awkward. We'll do it again. So Pivotal is we're a startup. We spun out of EMC and VMware in 2013. We're a modest startup with a few $1 billion valuation and 2,500 employees. Gonna get big one day. We're gonna get big. We are the new home of Spring. How many of you have heard of Spring? Okay, so Spring is a thing. RabbitMQ. Have any of you heard of RabbitMQ? Okay, good. Distributed message queue used by some small mom and pop shops like Huffington Post. Anybody heard of that? Yeah. Okay. Redis, a distributed data structure server, great for caching and influence the memcached protocol, used also by some small mom and pop shops like Twitter. Okay. Apache Tomcat, the leadership on that they're Pivotal employees. Anybody here heard of Tomcat? Okay, just making sure. I was just kidding. I know, you guys know what Tomcat is. Nobody uses anything else. Wait. Is that one guy who uses WebSphere here?
Yes.
The one guy who's always following me around. He's the same one who uses NetBeans. Same one. I give away hugs. Open source hugs. I'm here for you. Cloud Foundry. Anybody here of Cloud Foundry? Cloud Foundry is an open source platform as a service. It's a cloud, right? And a lot of people are trying to get the elasticity, the dynamicism of a cloud without having to pay or give up the privacy for things like AWS. It's not about removing their data center. They just want the dynamic sort of iteration and the agility that supports them. Cloud Foundry is perfect for that. It's also the underpinnings for some other cloud-based technologies. There's a small startup, which today means absolutely nothing. There's a startup now called IBM. Anybody hear of IBM? IBM. There are cloud-based technologies called Bluemix. It's based on Cloud Foundry. Anybody hear of another startup called HP? HP. They have a cloud-based technology based on Cloud Foundry as well. And at Pivotal, we care a lot about building applications for modern workloads, right? We want to support modern workloads, modern use cases. And for a lot of people, that means even if you're not deploying on the cloud, it means building applications that breathe naturally in the cloud, or that could, right? People move to this environment for a lot of different reasons. But one is for scale, another one is for organizational agility. So whether you're actually using the cloud or not, there's lots to be recommended by that transformation. So as part of that, Today we're going to look at Spring Boot. I'm out of slides. That was not nearly enough. I really should have come up with more slides. Darn it. This is going to be so awkward. Right, so we're going to look at something called Spring Boot. Spring Boot is it's a way of focusing attention on the concerns that are important in application development. It's a way of consuming the various Spring technologies. When we started our little startup in April of 2013, we said, what can we do to rapidly simplify, to dramatically simplify the development experience for modern Java developers? And what can we do to make it so that people can be agile? And we talk about agile all the time, but we really care about that at Pivotal. How many of you, in the keynote, they mentioned Pivotal Labs. Anybody hear of Pivotal Labs? It's a company. Every office in like 30 different countries, every office you go to, it's 2 people pair programming to a single monitor, single keyboard, no matter what. You work 9 to 5, you can't work to 5:01, you can't work from 8:45 or whatever, it's just 9 to 5 every day. We're very agile, we very much believe in that transformation. And so being able to deploy applications quickly, test them, get that continuous delivery and continuous integration story is very important. So we said, okay, what can we do to build applications that work well in the cloud, that serve this agility use case, and also to serve sort of modern technology use cases as well, right? There's a lot of stuff that doesn't look the same as it did when Spring was started. So that's Spring Boot. And there are a lot of different ways to get started. You can go to start.spring.io, that's what I do. It's a great kind of homepage. If you're the ASCII and curses crowd, you can do curl.start.spring.io and get this fancy menu. Isn't that awesome? That's my favorite. I keep waiting for them to install a Telnet version. That'll happen, maybe. But we're going to use this wizard here. It's just a web service. If you have IntelliJ or STS or whatever, you can use whatever choice you like. Can I use Okay, so we have the normal sort of pro forma stuff here, Maven, org, and group ID, group and artifact ID, the name, the description, the package name, the type of project you'd like to support. So you can choose a Maven POM or a Gradle config, or you can choose a skeletal directory structure, a Maven project or a Gradle project. You can choose a jar or a war. Now, if by some fluke of physics you happen to be stuck on 2001, then you should choose war. But for the rest of us, given that it is not 2001 and it is instead 2015, we're going to choose a jar. Now, this is in keeping with my philosophy of make jar, not war. Very, very important. So, again, we have 2 choices here. One for the I make bad life decisions and I'm stuck in 2001 crowd. One for the I want to build modern stuff crowd. Okay, so choose that one. Java versions. You have lots of choices here. 1.6. Who's using 1.6? You're among friends. No judging. It's very, very end of life. I'm just leaving that there. I'm just going to put that out. Leave that there where I found it. 1.7, as of last month, also end of life. So how many of you are using that? Again, no judging. No judging. Okay, so if you had your druthers, and I hope you do, choose 1.8. It's awesome sauce. Oh, gosh. So many more great people. Can you guys say open source? Oh, it's so good. It's so good. So if you had your druthers, choose 1.8. I love 1.8. Who's using 1.8? Ooh, you know, it's Chicago. How many of you are using 1.9? Just wondering. People here are awesome. Okay, so 1.8, good stuff. Choose the language of your choice. You could choose Groovy or Java. I'm going to choose Java because, you know, it's the track I wanted to be in, even if we're in the big gay one. Choose the kind of workload you'd like to support. So I'm going to say I want to build a web application. Great. I'm going to use JPA, but I could use Mongo or Gemfire or Redis or indeed any of the other Spring Data projects, including Neo4j and Couchbase and Cassandra and whatever, that aren't enumerated as checkboxes. For my embedded database for demo, I'll choose H2. I'll integrate with production. I'll use that. Great. I want a templating library, so I use TimeLeaf. So I'm just going shopping, really. I'm just choosing the bits I want to use. Maybe add some REST repositories. And hit generate. Now, what that'll do is give you a little zip file. Code generation. Don't freak out. Don't freak code generation. You don't need it. It'll save you 5 minutes maybe, which in a demo is a lot of time. Okay, so here we go. I've got a new folder here. I'm going to open it up in my IDE. This will work in any IDE, even NetBeans. One guy who always follows me around. It'll work in, it's just a regular Maven build, so you can use whatever you like. And the first thing we'll look at here is our build file. Can you all see that? No, I see. Font. Hello. That's paper. Okay. Legible? Yeah. You doing? Good. Okay, right on. So, basics, right? Nothing fancy. We have a parent build here. We're pointing to a parent build. This is just a. It has a section, a dependency management section that level sets all the common sort of ecosystem projects, all the Spring projects, all the things that Spring itself depends on, like the logging libraries and persistence and transactions and whatever. All of that stuff is level set here. We don't bring everything in. We just level set it so that if you do bring it in, you don't have to worry about playing with filling with version ranges and all that. Okay, so very, very convenient. And you can ditch this if you like and just use an import scoped dependency. Right, so it's a dependency whose scope is import, and that'll bring in the same. It'll do the same thing for you. Some properties, you don't have to set them, but they're very convenient. And dependencies, okay? And these dependencies are opinionated dependencies. They correspond more or less to the checkboxes that we selected on start.spring.io. So in the beginning, we said that we wanted to build a web application, and so we got Spring Boot Starter Web. We said that we wanted to build something that used JPA, so we got Spring Boot Starter Data JPA. And these are in stark contrast to the regular sort of Spring dependencies you're probably accustomed to with most projects. If you have Spring-ORM, Spring-ORM in the Spring framework supports JPA 1 and JPA 2. It supports Hibernate 3 and Hibernate 4 and Hibernate 4.1 and all the incredibly inconsistent, broken, incompatible versions in between, right? It supports JDO. Anybody here old enough to remember JDO? No? Okay, well. Anyway, it supports all of those things, right? So it'd be incredibly painful if, when you imported Spring-ORM, it transitively brought in all these different incompatible, completely redundant libraries. So we make everything optional, which means that it's up to you, dear developer, to pin down the version of which library you want to use normally. With Spring Boot, we've taken a different tack. We've said, let's go ahead and bring in everything they need to be productive out of the gate up front. So here, Spring Boot Start Data JPA brings in everything I need to be productive with JPA today. JPA 2, Hibernate 4, whatever, it's going to bring in the Spring transaction support. It'll bring in the Spring Data JPA module. It'll bring in the Spring-ORM library. It'll bring in everything and manage all the sort of dependency conflicts if they're going to exist for you. Which means you can just write code, which is all we really care about here, okay? So, I've got public static void main. I've got an empty static directory and an empty templates directory. I've got an application properties file, which is empty. And I have a unit test. So again, we did code generation, but you could have written this by hand, I assure you, right? This is just a Maven project with 2 classes that are empty and an empty text file. So our public static void main looks like this. It's a Spring Boot application. You can tell because it says, well, it says Spring Boot application. That's how you can tell. I think this annotation was really, really terribly named. If people just listen to me, nobody does on the team, I don't know why. If I had my way, this annotation would have been renamed, I want to go home early, right? Because it turns on the magic. This is the thing that makes Spring Boot so beautiful. You need this, okay? This is also going to turn on Java configuration. How many of you have used Java configuration in Spring? Spring doesn't care at runtime how you describe the beans that it manages. It just needs that information somehow. So if you're using annotations that are placed on component classes, and it infers that by the arrangement of these beans, like @outlier and @component, or if you define bean definitions in a single class using Java configuration, and then tell Spring that these provider methods are going to return beans that it should manage, that's another way to do it. If you do it in XML, that's another way. If you do it in Scala or Groovy, those are yet another way, right? It doesn't really matter. Spring just manages a big bag of beans. at the end of the day. They can all be injected to each other, they can all be referenced by each other. So this is going to turn on Java configuration. This class is, by association, also a configuration class. Okay? It's because it's transitively annotated with that configuration. It's also going to turn on component scanning. So everything in this package or beneath it will be picked up if it's annotated with @component or @service or @controller or @rest controller or whatever. And there we go. Now we can start writing some code. So I'm going to build a very trivial API, something nonsensically simple, so we don't have to focus too much on the domain, and we can instead focus on the code itself. Okay? How many of you have heard of OpenTable? It's a new app that's been around for like the last 5 years that lets you make reservations at a restaurant. It's super convenient because all you got to do is go to your phone, find the restaurant, look at the calendar, find some available times, see if you can get 2 people in there, or 3 or whatever. Maybe it's just you and a Java book. That has never happened to me. I mean, I don't know. That's goes to a restaurant by himself with a Java book. That's weird. So you do all that, try and make the selection, and then if it's still available, you confirm it, and then you get an email, and you can check the email and go to the restaurant. Now, that's way better than just calling them and say, I'll be there at 8, right? So we're going to build something of that nature, right? So we're going to say reservation, something like that. It's going to be a class. It's going to be a JPA entity, because that's what I chose. So I'm going to say @entity. I'll set up a primary key here, so it's going to be @related value. These are JPA annotations, nothing to do with Spring per se. We're going to say Spring, we're going to say private string reservation name. Okay. And this is Java, so noise. Okay, we need that. Get some getters in there. Get a toString. All right, good stuff. What else do I need? Reservation. Oh, I need a. Yes. Okay. Here we go. So now we have an entity, a JPA entity. We need a way to talk to the backend data store. In this case, we're using a SQL-based data store. It's a data source. We don't have to wire it up. We don't have to explicitly configure it. Because remember, you'll recall that I chose H2. It's an embedded in-memory database. There's, by the way, 2 spots up in the front here if anybody wants to fight it out and sees them. Right, so it's an in-memory memory embedded database. You can use it to run applications. Because we have them in the class path, or if we had HSQL or Derby, those would automatically be set up as a data source for you, absent any specific configuration. So again, we, in this case, haven't as much defined our own data source. I could, for example, do this, whatever, and that's my own Java config bean definition for a data source. Again, however I resolve that bean definition is entirely up to the code. This is Java configuration, but the whole point is that I want to define my dependencies here, do the wiring here, and my code, for what it needs to, depends on JavaX.SQL, that data source. The specific subtype and all that stuff it's the secret that we're going to keep in there, right? But since I have H2 on the class path, it'll give me an embedded one anyway, and that's great for a demo. So we'll remove that. We're going to write some code to talk to that backend data store. So I'm going to say interface reservation repository extends JP repository. And I'm going to make a repository object that works with entities of type reservation that have a primary key of type long. Okay. This interface is one Spring Data repository interface. There are many other such interfaces. You can use Cassandra repository or Couchbase repository or Neo4j repository or whatever. But the idea is that there are common create, read, update, delete style manipulation methods inside these repositories. So find all given a sorting condition, find all given a paging condition, save a collection of T's, save a collection given IDs and so on. Save and flush. This in turn extends paging and sorting, which is more generic, but not all data stores support that, so there's an even more generic one called just CRUD, right? So Cassandra is not going to be particularly great at sorting, right? But it will do create, read, update, and delete, like Couchbase. So different levels of specificity in each repository interface. You can choose the one you want. In our case, since we know we're using JPA, I'm going to use this binding, coupling JPA repository interface, which gives me everything I need. I'm not going to implement this interface. I'm not going to write that code, right? If you think about most repository logic, it's boring, right? Imagine, select one from foo or whatever. Select one by IDs, delete, update, etc. This is all boring, tedious code. Your boss is never, ever, ever going to pat you on the back and say, good job, you wrote a finder method. It's just not going to happen. Nobody cares. Nobody does. Nobody. I mean it. No. So don't do the code yourself if you don't need to. If you can close your eyes and see the Finder code in your brain, and it's just, even when you close your eyes, it won't leave you alone, it's probably not code you need to write. It's dumb code, right? So let the machine do it. That's what's going to happen here. You create this interface, and by virtue of the fact that it extends this, which is in turn a Spring Data interface, it'll get automatically implemented for you, and you'll be able to inject a bean of type reservation repository. Even better, I can say collection, reservation. I can create finder methods, okay? So I can say find by reservation name, string rn. And by convention, this is going to generate a method that is more or less equivalent to select all from reservation, where reservation underscore name equals rn, right? Roughly. But if I'm using MongoDB, then I'll get a BSON query. If I'm using Cassandra, I'll get a CQL query. If I'm using Neo4j, I get a Cypher query. You know, it's the appropriate technology behind the scenes. It's not going to be one API to rule them all, naturally. And of course, I can override this. I can say add query and plug in a specific, query statement if I want. But since I don't, we won't. Good. Now, I need to actually use this code. I'm going to define our first bean, bean of the day. Take a shot every time we define one. You won't get drunk at all, which is a bummer. This is a command line runner. It's an interface in Spring Boot. It has one job. When Spring Boot starts up, it's going to call void run, and you'll be given a callback to the string argument array that you see in public static void main. This is a callback interface. So any bean that you define that implements this interface gives this callback. It's just like the initializing bean interface in Spring, except instead of being a callback for the specific initialization lifecycle for a specific bean, it's for the whole application. So if you have any kind of back office processing code, any kind of integration code, batch integration, whatever, this is a natural place to put it. And any bean can implement this, so they all get called, as opposed to having to sort of munge everything inside of public static void main and have all these static variables and all that craziness, right? So we're going to say return new command line runner. And command line runner, by virtue of the fact that it has one abstract method, okay, in Java 8 parlance, that means that it has one method that is not implemented, is an ideal candidate for lambdas, right? Which is great. So I can take this interface, and if you think about what I'm trying to do here, I'm just trying to call the run method when the application starts up. That's all I'm trying to do. I'm trying to give it a function and say call this when it's ready. It's on click, except on boot or something, right? So I don't need this object. I don't need the pretensive state here. I don't have any state. I just want to call that method. And that's true for a lot of things. So Java 8 introduced lambdas, and lets me write this code like that. In point of fact, I can actually simplify it a bit further. I can say, since I'm only trying to call this one method, and I'm coercing this type into an object of type command line runner, the compiler, through type coercion, already understands